Hi class, today I'm going to go over a 1 proportion z interval. The goal of this video is to explain what a confidence interval is, to explain what a confidence level is, and how to write one, and maybe some calculator help too. So let's start with, what is a confidence interval? Alright, so the definition of a confidence interval is a range of values so defined that there's a specified probability that the value of parameter lies within it. So what that means is you're going to write a confidence interval because you may not know what the parameter is. Remember, a parameter is a number that describes the population. So maybe you wanted to know what percent of people like chocolate milk. Well, you can't really go around and ask everybody in the United States, do you like chocolate milk? So instead, you're going to take a sample and you're going to use that sample to estimate something about the population. So you're never going to get an exact answer, but you're going to get a range of values. And that probability that comes in, that has to do with the confidence level. The confidence level is the probability that the value of a parameter falls within a specified range of values. So what that means is, if you said that you were 95% confident, that means if you continually took samples of the same size and you went around and asked people, do you like chocolate milk? And you went around and you asked, let's say, 50 people. And you were to do this over and over and over again. And you were to write 95% confidence intervals, that means 95% of those intervals would have the true parameter. So you're never going to know how many people enjoy chocolate milk, but with all of these intervals, you're pretty confident that 95% of them will contain the true parameter. So you're going to get closer and closer. Okay? So let's do an example. All right. You notice that many of your friends do not speak another language. You take an SRS of 300 U.S. adults and find that 48 spoke a second language. So I guess you're trying to estimate in this problem how many people speak a second language. We're going to do that at the 95% confidence level. All right? There are 4 parts to a confidence interval. The first part we call state. And when we say state, we're going to state the parameters. In this case, there's only one. The parameter, well, I guess I don't need that because there's only one of them. The parameter is the true proportion of U.S. adults who speak a second language. And like we said earlier, the point of this is to figure out how many people speak a second language. I can't go out and ask the entire United States, so I'm going to take a sample, a random sample. And so what we're going to do is we're going to try to estimate the parameter using the statistic. So I'm going to write that p hat is used to estimate p. You're saying I'm going to use a statistic to try to guess what that is because I can't really find it in real life. All right, so those are the 2 things that you want to write when you state your parameter. All right, after you do your state, you're going to do what's called plan. You're going to show the planning portion of this. Show me, is it randomly selected? Is the sample randomly selected? Is the sample approximately normal? Is the sample large enough where you're going to get independence? So it says clearly here that the U.S. adults were chosen at random. And to check if something is, so we're done with that. To check if something's approximately normal, we do n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. We learned that back when we were talking about sampling distributions. So the problem here is we don't know the parameter. That's the whole point of this, is we're trying to guess it. So since you don't know the parameter, you can use p hat to estimate it. So instead of using the parameter, I'm going to put the statistic in for the parameter. Because if this is truly an unbiased study, they should be pretty close anyway. So it shouldn't really be that big of a difference. So 300 times 48 over 300 is definitely bigger than 10, and so is 300 times 252 over 300, okay, because these cancel out. So you're left with 48 is bigger than 10, 252 is bigger than 10. That means the distribution is approximately, don't forget approximately, normal. All right, and we just did that. Now let's check if the sample is independent. So what that means is I sampled 300 adults. Imagine putting every adult in a giant bag and selecting 300. Then putting them back in the bag, mixing up the bag, and selecting another 300. You want to make sure that if you were to repeat this many, many times, you're not picking the same people over and over again. So the way you do that is you want to see, is the population at least 10 times the sample? So is 300 times 10, representing 3,000 adults, does our population contain at least 3,000 adults? Definitely. There's, I don't know, I guess I should look it up, but I don't know how many U.S. adults there are, but there's a lot. So the population is at least 10 times the sample. And so we just checked all three conditions, which means we're ready to do this problem. And this problem is called a 1 proportion Z interval. So now I've told the reader what I'm going to try to estimate. Now I've told the reader everything checks out. I'm about to do the math. So that leads us to the next section called do. That means do the problem. So to do the problem, first we write down the formula for a 1 proportion Z interval. And if you need help figuring out how to write that formula, see me and I'll be more than happy to help you. Okay, earlier we said that 48 people out of 300 spoke another language, and that comes out to 0.16. So this is 0.16 plus or minus Z. And I believe originally we said a 95% confidence level. So you're going to go into your booklet, and unfortunately I don't have one here to show you how to do that, but I'm asking if you don't know how. You're going to look up what is the Z-score associated to 95%. Well, we know that 95% is about 2 standard deviations, so we know it's about going to be around the number 2. I just happen to know it because I do these every day, all day, so I know that it's 1.96. Remember that when you watch these videos, you should be pausing and doing these on your own and then checking your work with mine, okay? So we have 16 times the complement of 16 is 84. And then we have 16 plus or minus 1.96. Remember that this part right here controls the width of the interval. So this part right here is called the margin of error. All right, so 16 times 84 over 100, and the square root of that comes out to 0.0212. So this would be the standard deviation of the statistic, right? And this is how many of these we want. So this would be 0.0415. So the answer is 1185 to 2015. All right, so what this means is I don't know the parameter, but I'm 95% confident it's somewhere in here. So I'm going to write that down, and that's called your conclusion. I am 95% confident, and we write that so the reader knows at what level you tested it at. So I am 95% confident that the true proportion of U.S. adults who speak another language is between 11.85% and 20.15%. Okay? And then all of those parts make up your confidence interval. All right, so before we go, let's review how do you type this in your calculator. Okay, I did that clear, the last problem I just did, I did it just using arithmetic, but let's look at how you would use your calculator. Okay, so you're going to go to Stat, Test, and what we just did was called a 1 proportion Z interval. In a 1 proportion Z interval, it asks for X and N. X is success. So you were successfully able to find 48 people that spoke a second language. The sample size we chose was 300, and the confidence level we want is 0.95. And when you do that, it'll give you the same confidence interval we just calculated by hand, the p-hat, and the sample size. All right, guys, I hope that helps. Good luck studying for the test, and good luck with 1 proportion z intervals.